Assalamu alaikum dear students. My name is ISHFAQ HAMEED. I am working as a lecturer in chemistry at BHSS TARATHPORA. Today my topic is oxidation states of D block elements for class 12th. We have already discussed some points about this very topic in my previous lecture, and I will continue this topic to know few more pointers about this. The very first point is that when we move from left to right in a series, or when we move from left to right in a row up to the middle of the series, when we move from scandium to manganese, maximum oxidation states are stable, and those oxidation states involve electrons from S and D subshells. And when we move from manganese to zinc, high oxidation states are unstable. This means that when we move from manganese to zinc, those elements which lie between manganese and zinc, they will prefer to form compounds in lower oxidation states because those compounds will be stable. The second point is that elements which show maximum oxidation states occur in or near the middle of the series. I have taken an example here that in case of 3D series, the element manganese which is present near the middle of the series is having the greatest number of oxidation states and highest in the series. Greatest number of oxidation states means it shows +2, +3, +4, +5, +6 and +7 oxidation states. And in 3D series, manganese is that element which shows the highest oxidation state of +7, which we have discussed in the previous lecture. And the third point is that, before going to third point, I will continue, I will add a few more points here. That in case of 4D series, ruthenium is the element which shows the greatest number of oxidation states and highest oxidation state in the series. And in case of 5D series, osmium, which also lies near the middle of the series, also shows greatest number of oxidation states and highest oxidation state in 5D series as well as in all of the transition elements. And osmium's oxidation state is +8. The highest oxidation state of osmium is +8. One more point here is that D block elements, in case of D block elements, the oxidation states of a particular element only differs by unity. I have taken an example here. If we take an example of vanadium, it shows us 4 oxidation states. Vanadium, in some compounds of the vanadium, we see that vanadium is in +2 oxidation state. In few more compounds, we see vanadium is in +3 oxidation state. Vanadium is in +4 oxidation state. Vanadium is in +5 oxidation state. And you can see here all the 4 oxidation states of vanadium differ only by unity. They differ only by 1. But in case of non-transition elements, S block elements, P block elements, the successive oxidation states differ by 2 units. For example, I have taken an example of lead. Lead, in some compounds of the lead shows +2 oxidation state, and in more compounds of the lead shows +4 oxidation state. And these 2 oxidation states differ by 2 units. And when we move from top to the bottom of the periodic table, in case of D block elements, or when we go from top to bottom or down the group, stability of higher oxidation states increases. In case of D block elements, when we move from top to the bottom of the group, stability of higher oxidation states increases. This means that heavier elements will prefer to form compounds in higher oxidation states because those oxidation states for heavier elements will be stable. In case of P block elements, when we move down the group, stability of lower oxidation states increases. It means that in case of P block elements, the heavier elements will prefer to form compounds in lower oxidation states because those compounds will be stable. Example here, molybdenum 4 and tungsten 4 are more stable than chromium 4. It's because chromium is the element of 3D series and molybdenum is the element of 4D series and tungsten is the element of 5D series. When we move down the group, stability for higher oxidation states increases. That's why molybdenum 4 and tungsten 4 are more stable than chromium 4. In carbonyl compounds, oxidation states of transition elements is 0. When D block elements form compounds, and in some of its compounds and complexes, oxidation states of D block element which acts as a central atom, which acts as a central element, is 0. In case of, I have taken an example of CuCl. In this very compound, Cu, copper, has an oxidation state of +1. But in case of nickel tetracarbonyl, nickel has a 0 oxidation state. Nickel here acts as a central metal atom and the carbonyl acts as a ligand. In case of iron pentacarbonyl, iron has an oxidation state of 0. And that's why I have written here, in carbonyl compounds, oxidation states of transition elements is 0. Whenever a transition element forms a compound with carbon monoxide, which is called carbonyl, it acts as a ligand. It donates the shared pair of electrons. It donates both the electrons by itself to the central metal atom, and the iron and the D block element which acts as central atom has an oxidation state of 0.